Well, that is just awesome. Just over 20 minutes, we're at 50 degrees Celsius. So I've just received this parcel from Banggood. What's inside is a water diesel heater. This apparently is 250 quid's worth and has further discounts because it's Black Friday deal. So very simply, I'm going to do an unboxing. We'll break it down and have a good close look at all the components, and then we'll run it through a test and see what it's actually capable of heating. And I'm hoping eventually to use this for underfloor heating and a hot tub. So let's look inside. So first up is the instruction manual, and this is AFERY brand, by the way. We've got a good breakdown of all the parts, and it appears that we've got a good explanation on all the setup features, as well as all the troubleshooting, which is really handy. Right, so starting with the top, we've got the diesel heater itself. We'll strip this down in a second and see what the gubbins are like inside. Then we've also got the remote, the diesel pump. We have what looks like a relay switch. We've also got a control board, and it looks like there's an aerial in there, so we'll see how long distance we can operate this. And lastly, in the top, we've got a plug adapter. So if we go down to the second level, inside here we have the hot water hose. We've got the cable with all the plugs attached. We have a water pump. We also have hose pipe connections and what looks like to be a fuel filter, I think. We've got a fuel tank adapter, a mounting bracket, exhaust and muffler, combustion air intake. We've got the decent quality hard fuel line. And we've got various pipe connections, including 2 T-joints that are aluminium, and then we've got 2 plastic straight connectors and 4 elbows. So for 250 quid, we've got all this. Let's hope it works. So let's strip this down and have a look inside. So if it's anything like a regular diesel heater, this should be easy to maintain and replace all the parts. So I'm going to start stripping it down by removing this top cover. Right, so there's 4 bolts here and 1 little bolt here. I'm still unable to lift the cover off, so I'm going to see if I can remove these first now. Ah, they simply pop off like that. That's really good, actually. So if this is already attached to a hose, I can just simply undo that screw and lift those to one side so I can maintain the rest of the unit. So these are just press fit on, and there's little silicone O-rings just inside here. There we are. Try and make a note of those. So the point is, when I eventually install this, I want to make sure I have access to all the different parts. This cover, by the way, is die-cast aluminium. So what that's revealed is a retainer clip for 2 heat sensors. So let's have a closer look at those. So this one is your combustion temperature sensor, and that's simply pressed in there with a silicone O-ring. And this one here is your hot water temp sensor, and they look to be exactly the same. So this first cover is what houses all of the water. So let's take this bit off. So I'll firstly remove these 4 machine screws. Now we've got some Phillips head ones. These are a lot shorter, and now hopefully this should come off. There we are. So we can take a good look inside here now. There's a tiny bit of powdering to the aluminium there, but if we're going to get any limescale deposits or anything like that happening, it is very good that we can take this apart and have a look. And sealing that is another one of those silicone O-rings. It's a much larger one. This is quite an unusual size one, so we'll have to see if these are available. So now we should have access to the burn chamber. So this is the inside of the heat exchanger. That is absolutely squeaky clean. You can see all the fins to dissipate the heat. We've got a little hole here for the exhaust where there looks like to be another temperature sensor. Now, interestingly, that's threaded, but that wasn't threaded into it for some reason. And there wasn't a seal around that hole or around where the temperature sensor is. So that's the first potential for a leak. Now, the hole here seems recessed for another O-ring, so I'd be very tempted to just whack one on there just for good measure. Now we have the main combustion nozzle, and just looking at it, I think what I want to do is undo this bottom cover. Let's see if that comes apart now. So the nozzle lifts out now, like so. Fuel input can pop out. That releases the bottom cover. So it looks like this is a one-piece unit with not much else to take apart. We've got a glow plug here, and that's held in with just a screw. And then you've got your fuel input line just coming here. If I just undo the screw, which is very small, by the way. Now we can see if this glow plug comes out. And there you have it, a very simple looking glow plug. And that's it, I can't get access to any other parts of this burn chamber. But looking on the inside though, there does seem to be like a mesh. So if that mesh inside there gets clogged up, there is actually no way we can replace it. So I guess we must use super clean fuels in this burn chamber. Otherwise we'll have to replace this whole unit. So the glow plug is linked by these 2 wires to this plug here. That simply pops out. So the rest of this is the air pump and the control board, which should be inside here. We've got the 3 temperature sensors. So the exhaust one is the far right hand side, and the other sensors have a long wire and a shorter wire. The shorter wire goes to the far left hand side, which is for the water temperature, and that leaves the middle sensor going to the burn chamber. I think I'll leave those attached for now, just to make sure. But let's undo it here. Should come out now. So on the inside, we've got our motor for the blower and a special silicone gasket that goes around there. Make sure we don't damage or lose that. Now, quickly looking at the motor connection, there's nothing to really guide the position of it. So this could easily be turned one way or the other and you'll lose your way. I know it was that way that I pulled it out, so I'm going to put it back exactly as I got it actually. I'll check with the manual, but it might be if we turn this a certain orientation, then we can change the polarity or change it between 12 volt and 24 volt. Turn this over now. And lastly, look at the little turbo. There we are. Again, we've got a silicone O-ring around there, and the turbo spins nice and freely, which is good. So initially I was quite concerned on replacing some of those parts, but it turns out you can get them off Amazon quite easily. Here you can see a replacement burn chamber for £42. There we go, found another one for even cheaper, £32. And interestingly, we can actually get the mesh screens for this. So maybe there is a way of opening this up. No, I'm pretty sure that's all welded in. So you would hope to get many years before you'd have to replace one of those. I can also find the same style pumps, and if you don't know already, these are a Webasto copy. Right, so otherwise, everything seems to be easily replaceable. These little fuel pumps are really cheap, by the way, only about 20 quid each. The only biggest concern is the O-rings. Trying to get those exact sizes might prove to be difficult, especially the special ones, such as what's in the bottom cover and what's around the burner system. So we need to make sure we look after those exceptionally well. And other than that, everything looks in very, very good condition. So far, for what we're getting as far as manufactured bits wise, it seems like a good deal. But let's put it back together and see if it works all right. So in reverse order, I'll put the turbo cover back on. And now we'll put the bottom plate back on, making sure that gasket is in there neatly. But first we've got to make sure our burner's going in at the same time, haven't we? So that glow plug can go back in. There's that tiny little screw. That then slots into there. It's got indents to line it all up, which is nice. And then I'm actually going to put the burn chamber back on, and that will hold everything in there nicely. And while I remember, that heat sensor needs to slot into there, doesn't it? I think I'm going to undo it and then re-screw that back in. Yeah, that now seats nice and tight against there. So what I'll do is I'll assemble all of this housing and then re-screw that sensor back in. Make sure the O-ring is nice around there. Drop that back over. Right, I'll tell you what, this is a bit of a faff, getting that O-ring to sit nicely. If that doesn't sit right, we'll have a water leak. See, it pinches and gets stuck just at those joints there. But if I force it down, it's kind of rubbing against that gasket, but if we take it slowly, it might just work alright. Needs just a bit of persuasion, very gently tucking it in and around. And there, that's now in properly now. I'll put our 4 large bolts down it. And then the little screws. So now that's on, I can now tighten this heat sensor into the exhaust. Now again, I would like to have put a silicone washer in there. Considering this gets extremely hot, I can understand why they haven't put one in. But anyway, now I can put the bottom cover back on. Yep, that's not a problem. Oh, don't lose that O-ring. Now the glow plug can simply plug back in here. I don't think there's a polarity, so it doesn't matter which way it goes. These wires can tuck around there, like so, and come out the way. And then the bottom cover can go back on. There we are, that's nice and neat. So now we'll push the sensors back in. So those are in neatly now. They've got little guides to where the wires go, which is really nice to see. So we'll put in the retaining clip. And then I've just realised that this bolt here is not anything to do with the cover plate. This is actually for an airlock. So when you're filling the system up with water, you kind of bleed it here. And as you can see, it's got a little silicone O-ring on it. And just looking at the instructions very briefly, it actually tells you on the first page to release the air bolt. And it's basically saying if there's any air in there, you could damage your heater. But anyway, now we can put the cover back on. And finally, our water input and output. And whilst these are loose, we can actually change the orientation. This side is the output, this side is the input. There, well that was actually no bother at all. And very compact and very neatly put together, I say. Well, let's get it working. Right then, I've rigged it all together, so then let me show you how I've arranged it all. So if you didn't know already, these are meant to go inside a vehicle. So the idea is, this utilises the existing heating system, which basically means the heating system you've already got, you can use it independently from your engine, and therefore you're getting better fuel economy when you're parked. The other reason people use these is to preheat the engine before driving. Certainly in places where there is severe cold, freezing temperatures can stop your engine running. So from the comfort of your home, you can switch this heating system on, and both the engine and your heating system will be pre-warming. It's also used as part of a hydronic system, so a lot of van lifers would use this to have underfloor heating. Either way, they claim this has a 5 kilowatt output, and if you've seen my recent videos, you know I can run this on kerosene, which at this point in time is only 55 pence per litre, which works out to be 5 pence per kilowatt hour. Basically makes this one of the world's cheapest hot water systems, and theoretically we can run our own central heating with one. Right then, so let's systematically go through the setup. So the burner unit itself can remain horizontal, it can also flip on its side, or it can go vertical. I actually quite like the idea of having it in a vertical position. That way if a heat exchanger is filled with water, I can pull it down and it's kind of cupped it, if you see what I mean. And it saves springing quite a leak under here. I can literally put a bucket over it then. But never mind, for this setup I've got it in the horizontal position. So starting underneath, I've placed my fuel pump going vertically, and the direction of the cable attachment is the direction of pumping. Now if my vertical space is limited and I need all of this to be horizontal, the pump must have an angle no less than 35 degrees. So say your fuel line is coming in horizontal like this, your pump must angle at 35 degrees and then go to the burner. And the reason is so there's no bubbles getting trapped in the pump which can wear it out. Having it vertical is absolutely fine also. The exhaust must always point downwards, so you can see mine has a gradual slope on it, but let's say because you're limited with space, you have to have a little sag on the exhaust like that. Then you would have to drill a little hole just there to allow condensation to drip out. The exhaust and the air inlet must also be a minimum of 600 millimeters. That's important to create the right pressure balance for the combustion. So you can see I've clicked on the air intake pipe here, and I've attached the intake just above it here. Ideally, this also should be pointing downwards, so if there's any water or splatter getting into it, it can always drain back out again. For me, this was just convenient for the test. Next, we've got our water pipe arrangement. This is the output going straight to my water tank, and this is the input coming straight from the pump, and so you can see it's going to circulate this way through the centrifuge of the pump, that way, circulate around the burner and back out here. So I'm just using plain water in this system, but for better efficiency you can run glycol through it. So that will transfer the heat a lot better, as well as it will protect your system, whilst regular water could corrode this quite badly. And by the way, this is my workshop diesel heating system, so this uses a heat exchanger for hot air around my workshop, but you might be able to tell that I've made a heat recovery system for the exhaust. So I'm bringing your attention to this because it's worth mentioning that copper and aluminium shouldn't be together in the same system. I did it with this because I made this heat exchanger out of scrap, and I didn't have the right fittings to meet into the PEX pipe, so this copper is all I had. However, if I introduce copper into my new water heating system, what we'll end up having is galvanic corrosion, which could destroy all the aluminium. So if you were thinking of using copper pipes with this system, I would strongly think again. But we can use PEX pipe, aluminium pipe, high temperature rubber hose, and stainless steel pipe will work also. So moving on to the electronics, the main plug on the cable harness plugs just into the bottom here, and it has this retaining clip also. To remove the cable, we just pop off this little wire clip here, that drops the retaining clip, and then you can pull out your plug. And if you're ever wondering about the orientation, the two large pin inputs are on the left hand side of the burner, same side as the hot water input. There we are, back on. So my cable management as it is fairly neat. However, if I turn it round, you can see I've coiled up the cables at the back here. And that is not ideal, because the wires coiled up like this creates electromagnetism, which means they can then start interfering each other. So ideally, when it comes to a permanent installation, you want the cables to be just long enough. So again, I'm leaving mine coiled up just to do the test. So what I can tell you though is the main power lead is 1.9 meters. The total length of the wire that comes to controller is 2.4 meters. The wire coming to the water pump is 1.9 meters, which is the same as the diesel pump wire, 1.9 meters. Now the only thing I haven't added onto this system is the relay switch. This comes to a total of 1.2 meters, but between the burner and the relay itself it's 75 centimeters, and the tail from the relay is 45 centimeters. So this goes to the fan inside your vehicle. What you'll find is a heat exchanger with a fan on it, and so using the same wireless controller you can switch your car's heating on or off. And lastly, the total amount of water hose is 2.4 meters, and the internal diameter is 19 millimeters. So my fuel tank, which is full of kerosene at the moment, is 15.73 kilograms. So essentially once we've run the test, we'll weigh the difference, see how much fuel it's used. Now I've also weighed the water, and I've worked it out that I've got exactly 24.7 litres. I've also got two thermometers. I've got this one here, and this digital one. Both of them are saying 9 degrees Celsius. And I've also got thermal vision on my phone. So hopefully we'll get some accurate readouts. So lastly, I best point out how I'm powering this thing. This solar power station is by AFERY. In outputs 2,400 watts. So this is part of an ongoing test, and I can say it's an excellent unit. And it's mainly because, unlike the other power stations that I've tested, this has an AT60 connector, and the output is rated to 25 amps, which is far more than your standard carport adapter, which won't put out the correct amount of amps for you. So this is definitely the power station I would recommend. Otherwise, you can use a normal standard car battery and have it linked onto a 6 amp charger. Either way, your 12 volt output must be at least 150 watts. Which works out to be about 12.5 amps. But because of this awesome display, I'll also be able to monitor how much electricity this thing uses. That way, if you're relying on battery power, we know how long it will last for. Before we start, I'm going to mention this month's competition, and that is to win a phone just like mine. This is the Ulefone Armor 18T with thermal imaging camera. It's also got a standard camera with 108 megapixels. It also has a microscope. There are also additional modules you can buy that fit this plug here. You can use this for an endoscope or another microscope, and we've got a range of custom buttons as well. I like to use mine for the torch. So this retails for over 600 quid, but you can have it for just 5. And it's hosted by Raffles in the UK, and it's approved by YouTube. With every new video I try to run a competition, so you can see I've still got the Bluetti AC2A still running. And just the other day, someone won the AFERY. Well done, John Smith. I believe a brand new unit is on the way to you very soon. So by joining the competitions, you're funding me to give an objective review, which means I can be as critical about these products as much as I like. So that instead of pleasing brands, all I have to do is please you guys. So all the very best on winning. Let's begin the test. Right, so the aim of the test is to see exactly what the output energy is. So we have a set volume of water. We'll be able to monitor the rise of temperature over a period of time, which we can then use to calculate what the exact output is of this heater. We can also offset that against how much fuel we've been using, and therefore calculate the efficiency. And we'll also make special notes on how much energy is being lost through the exhaust, and get a general feel of how noisy this thing is also. So without further ado, let's switch it on. Alright, so after a few minutes of messing around with this, I think I've figured out how to adjust the controller. So we've got the on-off, we've got a settings button, and then we've got plus and minus. So if we just click on, that gives us our current time. To adjust it, we just press the settings button once, and then we can go plus or minus to adjust that, and then to save it, you press and hold the settings button. There you go, we've set the time. So to go to the next page, if you like, we'll press plus. This gives us our startup time. So basically, I can tell this machine to start up automatically at exactly 7 in the morning. And the same adjustment principles apply. So pressing the settings button once, that allows me to change it. Pressing and holding fixes it in place. Right, next page. This is the run time, so it will only run for a maximum of an hour. In between there, we can set how many minutes. Next page. This is the temperature limit. Now of interest, let's see how high we can set it to. A maximum of 90 degrees Celsius, so just below boiling. So next page, we've got A off. This is the automatic settings. So now we've set the timings and temperatures, we can now change it to set on auto mode, or we can operate it manually, which is what we're going to do now, I think. So I've paired the controller also. Let's see if we can turn it on. Oh, there we go. Right, so I'll set a timer now. Out of interest, what is the water flow like? Not much at all, actually. Hang on a minute. Right, well after a bit of messing around, we now have good water flow. Basically, there was an airlock and I used it to get it out. So now we're ready to get started. There we go, water pump's on, set the timer. Water temperature still says 9 degrees Celsius. I can hear the pump now kicking in. Current temperature is 11 degrees Celsius on the controller. And as you can hear, we've definitely got ignition. We're drawing about 140 watts. And don't worry, my garage door is open and I got a carbon monoxide detector. Oh, that's getting loud. It's about 1 meter away, 73 decibels. So 4 minutes in, we've already risen by 2 degrees Celsius. So as you can see, the temperature has risen drastically. So it looks like we're drawing about 52 watts on average. At 7 minutes in, we've risen to 21 degrees on the monitor. Barrel temperature says about 18 degrees there, and between 18 and 19 on this monitor here. And I can actually feel it warming up. Wow. So if I probe the exhaust now, it looks like we're averaging about 200 degrees Celsius. Alright, so we're now just 10 minutes in. The display says 27 degrees. The tank says 25 degrees Celsius, and I can definitely feel it, which is aligned with the thermal imaging camera. The thermal imaging isn't picking up the exhaust that well. I'll need to change the settings for that because it's shiny material. Interestingly, the heater itself is around about 40 degrees Celsius. Oh, got a bit of a leak there somehow. So I set it to half an hour. It's got 13 minutes left. Now risen up to 40 degrees Celsius. We're at 36 degrees in the barrel. That's on both monitors. We're running just on battery power, and this says it'll run it for about 27 hours. And that's averaging at 52 watts. We have got a minor leak somewhere. Most of this was from me messing around. I'll check it over, see where that possible leak might be. So within just 20 minutes, it's now hot enough to have a bath. That's 41 degrees Celsius. That's even a little too hot. Ooh. My actual workshop temperature is only 8 degrees Celsius because I've got the big door open. It's mainly because of the exhaust. And that is just awesome. Just over 20 minutes, we're at 50 degrees Celsius. And the rest of the unit isn't actually that hot. So our compost thermostat says 53 degrees Celsius. My kiln thermostat says 55 degrees Celsius. And my phone is saying 56 degrees Celsius. And the internal sensor says 58 degrees Celsius. And that was at 26 minutes. We've got just 4 minutes left. Alright, so we're at 60 degrees Celsius. 2 minutes left. There we go. This is automatically shutting down now. We have reached half an hour. Final temperature readout, 66 degrees Celsius. And now it's running its cool down cycle. The airflow will basically stay on for a few minutes. So now I've got 15.56 kilos left. But the real thing to note is how excellent water is as a thermal mass. And at 5 pence per kilowatt hour, that is excellent value for money. I am super excited to build a hot tub now. Now, a wood-fired hot tub is awesome, but the thing is, I can have this ticking along during the day and not have to maintain it at all, so that when I'm finishing work, I can just jump in it and not have to start the thing. A wood-fired one isn't so convenient, which is why this is awesome. Out of interest, can I get this to automatically start? Right, I've set it to go off in 2 minutes. There we go. It's working. It's still at 60 degrees Celsius. Let's start it up again just fine. Well, I think that's a wrap. We'll turn it off. So then, I've been crunching the numbers. So we've got 24.7 litres of water, started at 10 degrees Celsius and went up to 66. We used 0.21 litres of fuel, which equates to 2.04 kilowatt hours of energy in 30 minutes. So here's what I figured out. The overall efficiency is 79.02%, which means our heat output was 1.608 kilowatt hours, or 5,488.22 BTUs. That's a British thermal unit. Or for the scientists among us, it's 5,789.88 kilojoules. So I worked that out to be 3.2 kilowatt hours per hour. So I wouldn't call this a 5 kilowatt hour unit. I would say it's a 3.2. So the running cost for heating oil or kerosene at 55 pence per litre is 17.6 pence per hour. But let's say if we go to the pump and run it off regular diesel at £1.40 a litre, then running this is 42.3 pence per hour. So considering the 79% efficiency rating, the price on the outputs per kilowatt hour, on kerosene it's 7 pence, and on regular diesel it's 28 pence per kilowatt hour. So here's some other figures I figured out. To run a bath, let's say, so an 80 litre bath, which I think is the average, on kerosene is just 19 pence. Or if we use regular diesel, it's just 38 pence. That's raising it to a temperature of 40 degrees Celsius, which is pretty hot. But let's say we ran a shower unit with this, call it 30 litres of water. Well, on kerosene, that's just just 7 pence a shower. And again, using regular diesel, it's just 14 pence for a shower. So I'm going to leave a link to my calculations in the description, which is basically me having a conversation with AI. So if you're a mathematician and you want to go over my figures, then do leave me a comment and tell me what you think. I very much appreciate your feedback, and I ask you to double check everything that I've said. Believe it or not, I failed all of my subjects at school, and mathematics was my worst. But look at me now, teaching PhDs how to save money so they can pay off their student loan. Sorry, I shouldn't gloat, but I would like to encourage people that you don't need to get into student debt. You don't always need a certificate to go out and do stuff. More often than not, in my professional career, people pay me to get the certificates, but that's because I learned how to use these. So lastly, moving forward, what would I do as far as design changes? Well, firstly, I want to achieve at least 90% efficiency, so I'd want to reclaim as much of the heat energy from the exhaust as possible. Now for that, I could use a second-hand EGR cooler and run the circulation through that also, or if I've got a big hot water tank, I would run the exhaust through it as well. Now I did prime the system with water prior to using it, but to make sure there are no airlocks, I would try and create some sort of a valve up here, or include some sort of expansion tank or breather tank where all the air bubbles can collect and then I can vent them off. We can put the pump in a box full of wool like I did with my other diesel heater. That will significantly quiet everything down. I should have used a muffler on the exhaust. That would make that a lot quieter as well, because as it was kind of acting like a trumpet, which is why it was so loud. Things to note, if I actually installed the aerial, this has a range of over 800 meters. And something else I'm very impressed with is how much electricity this uses. It actually only consumes 39 watts of power. The 55 watts that you saw on my battery is because I had additional lighting that was on. So if you're paying about 25 pence per kilowatt hour of electricity and divide that by the 39 watts, barely registering a penny. It does have a glow plug that goes to about 150 watts. That's within the first minute. That's like any other burner system. But the cost of that is so minimal, it's not worth worrying about. Put it this way, a small solar panel could run this. I'm actually thinking for the hot tub not to run the water through it directly, and to instead fill this with antifreeze or glycol and run a coil at the bottom of the pool. That way I haven't got to keep on thinking of repriming this. That way the heat transfer should be better. If it's cold weather and the pool is empty, I haven't got to worry about any water or anything being in this, which could crack the pipe if it freezes, and so it should simplify everything as far as filling the pool up. I haven't got to worry about priming this or anything. And so if you want to see that and this video is helpful to you, then please like and subscribe. It costs you absolutely nothing, but it means the world to me. And that way I can find a lot more cost-effective solutions for you. So can I recommend this video? And if not, can I encourage you to use your own handy pandies, get out there in the real world and forge for yourself a life worth living. I'll see you in the next episode. Bye bye.